All right, Algebra 1. Chapter 1, Section 1, Variables and Expressions. So, um, basically, this section is all about the anatomy of the algebraic expression, which is basically anything that is a combination of adding, subtracting, multiplying, dividing, exponents with variables and with numbers. And so, if you remember, hopefully, variables are just different letters we use to represent. It's kind of like a placeholder for some value we may not know yet. Maybe we do know it, and we're just putting it in. We're putting it in there so that we can change it later. There's all kinds of different reasons why we have variables like x or y, but like 4x is an algebraic expression. You could have 2x to the third power minus 4y to the 1/2. There's all kinds of different things that can happen here with this. You get square roots in there. You could have, hopefully you remember absolute values. There's all kinds of different ways that we use these algebraic expressions. When we have a combination of them, like 4x plus 2, that is an algebraic expression, but each of the parts actually has a name as well. So the 4x is actually the variable term. The 2 we call a constant term. And the reason why we have those specific names is the variable term tells you there's a variable of some type in that portion of the expression. The constant term tells you it's just a number. It's not going to change at all. There's nothing in there that's going to change it. It's just a number. One thing to talk about too, and a lot of the purpose of all this is to really understand the vocabulary that I'm going to be using throughout all my examples. So if you don't understand what it is I'm talking about when I'm talking about it, it's going to be hard to understand the lesson. For example, you probably know what you get when you multiply 4 times 5. You get 20, right? Now, the important part here is that you know that 20 is the product or the result of that multiplication. And 4 and 5, those are the factors. The two things you multiplied to get that product. Now, factors can also be something like 4x. 4 is a factor, and x is a factor. And if you know anything about factoring, the process of finding those things, you probably know that 4 is the same as 2 times 2 times x. So that's another way to break down the factors even more. Now we have more factors involved in it. It's still the same expression. It's just represented in a slightly different way. One thing with multiplying is we have lots of different ways of showing it. So we can have 4 and we use the little x times 5. That's how you probably first learned how to the symbol for multiply. 4.5 is another one. We start using that one in algebra a lot because the x is often a variable, so we don't want to confuse, am I multiplying or is it a variable? So we use a dot instead. Notice how it's not at the bottom. Like this represents 4 times 5. 4.5 is a constant term. It is just a specific number, 4.5. So you have to be very careful to make sure that your dot is in the middle. Maybe you don't like dots though. You also can do it with some combination of parentheses. If we leave it blank, that means it's multiplication. And it doesn't matter which one has the parentheses. The first number can, or the second number, or they both can. Like you can have x times y and have them both in parentheses. So all of those different expressions right there, those all mean multiplication in some form. So we use them interchangeably. We generally don't use the 4 times 5 with the x symbol for multiply in algebra. We use one of the other ones. But at any given point, I might switch between them, and that's just, after you get used to all of them, they all mean the same thing, so you just write the one that's most convenient for you at that moment. A lot of math is all about convenience. So, you also have exponents. So if you've ever seen something like 2 to the third power, you know that means, hopefully, 2 times 2 times 2. So 2 multiplied by itself 3 times. The 2 we call the base, and the 3 we call the exponent. And the result here, 2 times 2 is 4, times 2 again is 8. That's just the result of it. Another name for exponent is also power. We use those two interchangeably as well. Whatever feels best for the sentence that you're using it in, that's usually how you say it. These problems are usually blank to the blank power, where here you have the base, whatever the base number is, and then you have the exponent in the other spot. So for this example, I keep saying 2 to the third power. That's the sentence that I use. You also, there's other special ones, like anything. Oh, let me actually undo that last little bit there. Let's do 4 to the second power. We just call that 4 squared. That's the common shortcut there. If you have 4 to the third power, we would just say 4 cubed. And that's just because of the nature of what the second power means and what the third power means. If you're familiar with area and volume, that will probably make sense to you. But that's all the breakdowns of all like the different kinds of expressions and how we'll talk about them. I'll use those terms a lot, so get familiar with them. And if you have trouble understanding one of the sentences I'm using or one of the examples or problems in your book that you're reading, try to use this kind of information to decode it. Because a lot of what we're going to be doing is processing all of our words and math interchangeably. And that's actually the first example we're going to work on here. We're going to write verbal expressions. And you can see here, oops, I did not choose my highlighter. I'm on my highlighter. A verbal expression is like when you're trying to convert the symbols of the math problem into something that you can write out like it was spoken. Think of it like, how could you talk to someone on the phone about one of these problems? So what we're going to do is we're going to break it down into the parts that we have inside of each of the terms and learn and figure out how to describe those, and then the relationship between the different terms. And that's what example 1 is what we're going to do. So if I notice here, I have a couple things going on. I have 3 being multiplied by an x, right? We have 3 times x, but that x also has a power to the 4th. So if I were to think about each of those things individually, x to the 4th, no, I'll write it out in words here, 4th power, that's this part of the equation, right? Those match up there. I have to have the 3 times that though. And for that I would just say something like 3 times, or I could say multiplied by and either one of those would work fine. You just have to choose the one that is the best for you. All right, 3 multiplied by, well, that's the first part in pink there. So now all I got to do is make sure that these things are combined together properly. 3 multiplied by x to the 4th power. And there is the verbal expression that represents that algebraic expression. Now we got another one down here. We could see this, and this is an important thing to know about math. It's all always connected together. It's always just one little step further. If that all made sense to you, how we wrote that down, then this part, this term of the next expression that we're going to translate is the same exact thing. So I don't need to break that down anymore. I know that that whole part circled in pink there is 5 multiplied by z to, you know what? Yeah, to the 2nd power. So now I know that whole term of the expression there. Now we just need to add that constant term in the end. So we could just say plus 6, because that's how we normally say it when we're being casual about the math. If you want to be a little bit more technical with it, when you add, it's a sum. So I would say summed with 6. But if instead of writing that, if you didn't want to write that, if that was too fancy for you, you could just say 5 multiplied by z to the 2nd power plus 6. And you would be just fine with that result as well. So it's all, you got to think about your comfort level a little bit, make sure that you're getting the right idea across, but you don't need to have it be too fancy of wording if you don't understand it. Choose the level of wording that you understand. Okay? I'm going to end this video here, and then we'll pick it up in the next video.